All right. So how did the exam go? All right. So we're going to go over that today. Again, remember that the policy is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam score with the what you earned on the final exam. I posted on Slack yesterday, but you might have noticed if you go through all the assignments past spring break, I changed the contents of all them to be determined, so that we can play a little catch up and make sure we are practicing the stuff that we're getting to in class. So we'll hopefully get back onto a footing since we fell a class and a half or so behind. Okay, so questions about any of that? All right, so let's go through the exam. I assume everybody did the exam. Well, if you didn't, it's too late now. So it's just, I guess it's a moot point. So let's see. So what does it mean for Python to be loosely typed and interpreted? Well, loosely typed means you don't have to define the kind of value you will be storing in a variable. Interpreted means the program is converted to low level at runtime. Overall, this means that Python is a relatively slow language compared to strongly typed compiled languages. Something along those lines. All right. Next question. Convert. This guy right here, 100111101 from binary to decimal. So I'm actually going to copy this value here. This is our pattern where we start at the far right and move to, this is the ones place, the twos, the fours, the eights, the 16s, the 32s, the 64s, the 128s place. So this is 1 times 128 plus 0 times 64 plus 0 times 32 plus 1 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. It should be 157. Questions on how we did that one? So that was that pattern where we start off. This is the ones place, so it's 1 times 1 plus 0 times 2 plus 1 times 4 plus 1 times 8 plus 1 times 16 plus 0 times 32 plus 0 times 64 plus 1 times 128. So that's why I only have the ones that didn't have zeros in it down here, because otherwise I would just be adding a 0. Okay, so that is that one. Convert 1328 from decimal to hexadecimal. This is the other pattern, right? Where we divide this over and over and over again by, in this case, 16. Record the remainder. So 1328 divided by 16 is an 83. Remainder 0. 83 divided by 16 is a 5. 5 times 16 is 80, so we have a remainder of 3. 5 divided by 16 is 0. 16 goes into 5 0 times. 0 times 16 is 0 with a remainder of 5. We then read our answer from bottom up. This is 530. Make sense? All right, so that was us working with both of our patterns from going from decimal to a base or from base to a decimal. All right. Next one. Write the necessary code to display all of the odd numbers between 1 and 100,000 to the screen. All right, let's just do it this way. So we're going to say for, is there a way for me to turn off the formatting? Let's keep going. For I in range, that when we go, they want me to go between 1 and 100,000. You could decide whether that means everything in between or inclusive. It doesn't matter. 1 to 100,001. And I want to display only the odd numbers, so I can do a couple different things here. I can choose to ask the question. I'm going to go ahead and do that. I'm going to say, if I mod 2 is equal to 1, that means it's an odd number. Therefore, we'll print out I to the screen. So this is display all the odd numbers we're displaying, so we're going to be printing something. Odd numbers, so only the numbers that when divided by 2 have a remainder of 1. And in the range of 1 to 100,000, range goes up to 100,000 and, well, it goes up to, but not including your second number. If you said 0 to 100,000 here, that's fine. If you had everything else the same, because you can interpret what I mean by between. 1 in 100,000 or something like that. So that's one way you could have written this. Another way you could have written this would have been to say step by 2 and then just print out every value. Start off at 1, step to 2 goes to 3, step to 2 goes to 5, step to 2 goes to 7, so on and so forth. I prefer this one because this one exemplifies that idea of remembering stuff, asking questions, repetition. I mean, this builds in the definition of programming into a nice little nugget. Go ahead.
I think I'd adapt by replacing the equal sign with the not equal operator and having it be 0 instead of 1.
That's fine. Yeah, so if you want to,
Yeah,
so if you want to say if this is saying it's not even, all those solve the problem the same way. This says if it's odd, print it. This says if it's not even, print it. This one just says print everything, but I'm stepping by 2s. Make sense? All right, so that was an approach to that one. All right, this one should be ingrained in our souls by now. In fact, if there's a question that effectively represents the entire art of programming, it's this question. You know, how does Python represent the following ways humans solve problems? Memory, asking questions, and repetition. We do memory through variables. We do asking questions through conditionals, so like if statements. And we do repetition through loops and functions. And remember back to, week 1 of class, 100% of programming languages will have facilities for these 3 things. 100% of them. Go ahead.
Are there other things that fit into the category of conditionals, or is it just statements?
There actually are. There's these things called switches, and most languages have the idea of an if statement or a switch. I tend not to use switches very often. I prefer if statements. So the answer to your question is yes, there are. There's also something called an inline if in a lot of languages, but generally we're talking about if statements, asking a question. All right, questions on that one? All right, and I mean, if you roughly gave me an answer that's in the spirit of this question, that's fine. I'm not gonna, like for instance, if you said loops down here but didn't say loops and functions, I'm fine with that. If you just said functions, but if you didn't say either of those, probably not so fine with that. So you gotta give me something that shows that you understand the breakdown. All right. Write a function that takes a string as a parameter and returns the number of spaces in that string. Note that the space is the character, single quote, space, single quote. All right, so we're writing a function, not just code, but a function that takes a string as a parameter and returns the number of spaces. So maybe we call this guy, so def count spaces. This guy's going to take a string as a parameter. All right, I'm just naming it a string. And this should return the number of spaces in that string. So we're going to be counting the number of spaces. So maybe I'll start off a variable called count and start at 0. I want to go through every character in my string. So I can do this either for doing a range for I in range and use that to access each thing. I'll show you both versions. So I can say for C in a string, if C is equal to the empty character, or the space, we'll say count plus plus. Ultimately, we will return count. So remember the current count, go through every character in the string, ask a question, is that character equal to a space? If it is, increment the count. After I've gone through all the characters, I'll return that count. Not print it, I'm returning it. Returns the number of spaces in the string. Go ahead. You could, count plus plus should work in Python. You could say count plus equals 1, or you can say count is equal to count plus 1. An alternate version of this one might be for I in range 0 to length of a string. If a string at bucket I is equal to a space, increment count. These two things do the same thing. This guy makes C equal to each character in turn inside of a string. This guy makes I equal the indices of a string, and then I'm using that index to access an individual character. You can choose which one makes more sense to you. But important thing here is you're writing a function. So it's got to be a function, not just code laying out there in the middle of nowhere. It's got to return something. So understanding the difference between return and print. And then this guy, again, is drilling the idea of remembering something, doing some repetition, asking some question. Make sense? Go ahead.
So does returning sort of like make like count spaces equal to like the count?
Yeah. So somewhere else in my program, I might say, answer is equal to count spaces of hello. Let's do hello world. I put a couple extra spaces there at the end. So now this function will take in hello world as a parameter. That'll come in as a string. This guy will do all of its stuff and ultimately return count. So this whole thing here will boil down to the value of count, and I'm storing that inside of a variable called answer that I could choose to do something with it if I want, or I can choose just to forget about it. But again, I can also then have a second parameter calling the same function again, but with different inputs. And it will give me a different count for number of spaces because I'm passing in a different value in for a string. That's the purpose of functions, is we can write them once and then use them multiple times to perform the same task on different inputs. All right. More questions on that one? All right. Let's see. Write a function that takes a string as a parameter and returns that string in reverse. So again, we're writing a function that takes a parameter. In this case, we want the parameter to be a string, but since we're a loosely typed language, we have no way of defining the kind of value we expect. So the way we can accomplish that is giving it a good name for what we expect it to give us. Give us a string, so I'm going to call it a string. So we're going to call this define reverse string is going to take in a string as a parameter. All right, and we are reversing this string. Strings are what are called immutable, which means we cannot directly change them. So we're going to, if we need to make any alterations to a string, we have to build up a new string through concatenation. So I'm going to maybe create a variable here called answer. I'll start it off as the empty string. And I'll go ahead and walk my string that was passed in backwards. So I'll say for I in range of length of a string minus 1, which is the last legal bucket in a string. Keep going all the way up to and including 0, or all the way down to and including 0, and take steps of size -1. So this is our loop that goes backwards, stepping by 1. Each time through, we're going to go ahead and say answer is equal to answer concatenated with a string at bucket I. And then we'll return answer at the end. So this will walk through my string in reverse, building up a new string with each character from my old string, giving me the reverse version of that string. Another approach to this would be I could have walked through the string forwards and when I built it up, just build it in reverse. So this would have had the same output because I was going through it forwards, but each time through I tacked the current character I was looking at onto the front of my string, which would have built it in reverse. If you want a third version of this, since we didn't actually need to, for this version, and we didn't need to actually have the index, I could say for C in a string, and I can say answer is equal to C concatenated with a string, or concatenated with answer. Build it in reverse by always concatenating onto the front. right? So all three of those will solve the problem. I think the one that maybe makes the most logical sense is I want to build something in reverse, so I will walk through it in reverse. This guy right here. Start at the last legal bucket, go all the way up to and including the first legal bucket, take steps of size -1, build my brand new string, and then ultimately return it. Make sense? All right. What does the following code do? All right, so we got this function called do something. I'll do something else. It's takes in a list of numbers. Again, we're dealing with a loosely typed language. So I purposely named my parameter something that is meaningful for what I expect you to pass in. I expect you to pass in a list of numbers. Okay, we have this variable called a. We're remembering something that starts off at 0. We're going to go through all the values in list of numbers, and we're going to say a is equal to a plus that value. Ultimately return a. What does this guy do? It returns the sum of the values in a list of numbers. That's what that function does. Goes through the list, adds every element up, returns that sum. Make sense? All right. Next one, write a function that takes 2 integers and returns the larger of the 2 integers. Sorry, I just got more coffee than I should have gotten on my keyboard. All right, so function that takes 2 integers and returns the larger of the 2 integers. So maybe we have a function that's going to be def, maybe called FindMax, that takes in a num1 and a num2. And we ask the question if num1 is greater than num2, return num1. That's the bigger of the 2 numbers. Else, return num1, or num2 rather. So take in 2 numbers. If the first number is bigger than the second, return the bigger number. Otherwise, return the other number. Good. Then it doesn't matter which one you return. If they're the same, I'm returning 5 either way, right? So if they're equal to each other, we'll get into this else. And I'll return num2, which is identical to num1, so it didn't matter which of the 2 we returned. All right, questions on that one? All right, and lastly, what does the following function do? What does the following function do? Give an example of sample input and output. I think I probably said to do that in the last one too, but do something else. So this guy takes in an S1 and an S2. It's asking about the length of those guys. So these guys are probably collections, right? So it's saying if the length of, and we're using the plus sign here, so these guys are probably strings. We're doing concatenation. So if the length of S1 is greater than the length of S2, we'll return S1 concatenated onto S2. So S1 will come first. Otherwise, S2 will come first. So this guy returns a string that has the larger string concatenated onto the front of the smaller string. And to give a example, so let me left justify this. If I were to call do something, let's say A is equal to do something hello and elephant. Elephant is definitely longer than hello, right? So hello will come in for S1. Elephant will come in for S2. Is S1 longer than S2? It's not, so we're going to return S2 concatenated with S1. So this guy would, if I printed out A, this would print elephant hello. The longer string concatenated onto the front of the shorter string. All right. Questions about that one? All right. So I think, is that all the questions on the exam? All right. So that's all the questions on the exam. So I'm going to reiterate something I said last class. If you sat out there today and as you saw me solve each of them, it made sense, the final solution, you're right where you should be. Many of you, I suspect, had trouble, especially on the programming ones, writing it yourself from scratch, even though you see them now and they're like, okay, well, that wasn't all that much. I suck, I'm stupid, I don't know what I'm doing. Reps, 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 reps. It takes practice to get into this stuff, even though they're relatively simple little things. Write a function that does something, takes a couple of parameters, asks a question, returns an answer. Okay? Right now, where you're supposed to be is having trouble getting started on questions, writing it yourself. That's why I want you working in groups and things like that. Where you also should be is when you see something like this, you should understand, it should make sense to you when you see the answer. All right, that makes sense? So if you see this answer right now and it still makes no sense to you, then we should probably have a discussion. But if you said, I couldn't have written that myself, but it made plenty of sense to me when I saw the answer, you're probably right where you should be. Eventually it'll click if we keep putting in the reps and keep putting in the time. So the question I would ask yourself is, are you working hard enough on the assignments? Are you asking yourself the right questions? Are you relying too much on your group to give you the answer and not focusing on learning the stuff? Again, go back to the idea that programming is like a sport and you have to put the reps in. And if you're not putting those reps in, even if it feels like it's taking a unreasonable amount of time outside of class, it's the nature of the beast. And eventually you'll have this superpower that you'll be able to go and earn a lot of money with. All right, that's the punchline of all this stuff. All right, so questions on any of that stuff? All right, so I expect to have the exams graded by Wednesday. I won't be able to do them tonight. I'm giving a talk in Green Bay, but tomorrow looks pretty open. So I'll get through them so you kind of know what you have going in to midterm. I think I have to have the midterm grades in, I don't know, end of the week or something like that. But in any case, remember, doesn't matter how poorly you did on this exam, you can replace it with 100% if you do better on the final. All right, so use this as your own measuring stick of where you currently are relative to where you should be. And I would say the percentages on the test are going to give you a pretty good indication. If you're, if you got a 70 or better on the test, then you are probably, doing all right. If you sat there around like a 20 or a 30, which means that you really didn't even know how to start most of the questions, then you're probably lagging behind, and hopefully in the next 8 weeks, it clicks. All right, but make some adjustments to your current study habits or whatever to get you to that point. Maybe you're just a person that things don't necessarily come as quickly to. So then thank God you have the backup plan of the second exam being able to replace this first one. All right. Okay. So today I want to start talking about objects. And we're going to go a little bit off script from the book. So one thing I'm going to do is the second 8 weeks, I'm going to start deviating from the book somewhat and kind of using my own examples and own questions. I think that might be more beneficial based on some of the feedback I've been getting at this point. So let's think about what we have so far. We talked about procedural versus object-oriented languages, right? Remember, we had that example of the telephone that was a big pile of wires up here, and I said, you walk in, you see the pile of wires, that's a procedural language. And up to this point, we've been using Python as a procedural language, even though it is an object-oriented language in that it supports objects. Where the object-oriented version of a telephone would look like a phone. And we believe all those details, all those wires, that stuff is inside of there, but we don't necessarily have to work with those wires very often. We're only working with the aspects of the phone that are part of our daily needs. All right, so what is an object? An object in Python and in most languages is represented through something called a class. And we'll look at this. A class is a collection of fields, constructors, and functions. Fields are the values an object remembers. Constructors are like functions, but initially set up an object with its starting state and values. So constructors are only used at the very beginning when we first create what's called an instance of an object. And a function is like the functions we've already been dealing with. These guys are functions that typically operate on the fields of this object. They don't have to, but typically the idea of having a function inside of an object would mean that's something that object knows how to do. All right, we already seen some examples of this, like with strings, with they know how to write justify themselves, padding out to a certain number of values, that kind of stuff. They know how to convert themselves to uppercase. They know how to convert themselves to lowercase. All right, so this is the idea of an object. Now, what I'm going to go ahead and do is I'm going to say, so let's review dictionaries. Dictionaries are a collection of, the book calls them key value pairs. I almost always say name value pairs. And really, you can think of this as a collection of variables and their values. That's what a dictionary is. A dictionary doesn't have to hold the same kind of values. You can have a first name equals Mike, a last name equals Littman, and an age of 21, and those, you have two strings and an int inside of a dictionary. It's perfectly allowed, and it gives you one nice little package to hold several pieces of information that might be related to a person. Okay? Now, what's a weakness of dictionaries? And this isn't necessarily a weakness. It's probably the best word we can use here. But, generally speaking, we're going to say that we want to use the right tool for the job when we're solving any problem. Programming problems, real life problems, doesn't matter. We want to use the right tool for the job. Dictionaries only allow us to hold name value pairs. We can represent pieces of information given the name and associated with a value. That's all we can do. We can't operate on those things internally on the dictionary. If we want to have functions that work with that dictionary, we have to write them externally. Write our own functions that, for instance, the fantasy game. question that had you take in a dictionary of an inventory and print out the current stuff in their inventory. So you operated on a dictionary through a exterior function. Make sense? All right. So that doesn't mean dictionaries are bad, but they are limiting. They can't do things to themselves that are specifically related to the data that they're holding. So they can only hold name value pairs. They cannot perform their own functions on those name value pairs. So we might look at classes as being upgrades to a dictionary. And what I'm going to do is I'm going to start off by showing an example of a dictionary representation of a fraction and an object representation of a fraction. All right, now, dictionaries, well, we know what fractions are, like 1/2, 3/4, those guys. Okay, so been doing those for a while. So we decide that in our world of programming, we want to represent fractions. All right, so I'm going to maybe call this guy a fraction. And we're going to set him equal to numerator is 1. Denominator is 2. And then we can print out a fraction. And there's what our fraction looks like. All right. Now we might decide, you know what? I'd like to make our fractions print a little nicer than that. So maybe we have a function called print fraction. And this guy takes in a fraction dictionary. And what he'll go ahead and do is he'll say, I'm going to build a string up. Those will give us a chance to practice F strings again. So I'm going to say answer is equal to an F string, so a formatted string that lets me embed elements in it rather than having to do the crazy concatenation stuff. So I'm going to say answer is equal to, I want to get a fraction dictionary. This guy at bucket numerator. Actually, am I going to be able to do it? I don't think it's going to let me do that. I guess we'll find out. Just because it's embedded in here, I don't think it's going to let me do anything special. So what I suspect we're going to have to do is this. And then we're going to maybe put a little, a slash. So like 1/2 would be 1/2. Maybe that's what we make it look like. And then the second thing will be the denominator. All right, so we'll build a string and answer. That's going to be our numerator, followed by a slash, followed by our denominator. And we'll go ahead and print answer. So now, instead of printing a fraction, we'll call print fraction, passing it a fraction. Oh, they can't include the backslash. So let's see if they just treat it then. well, here, we'll do this. Numerator is equal to a fraction dictionary at position numerator. Denominator is equal to a fraction dictionary at position denominator. And then we'll say numerator in here and denominator in here. And there's our 1/2. So the formatted string, the F string, didn't allow me to use the double quotes, the backslash on the double quotes here, so I wasn't able to get those things directly in there. But this allowed it to print. If you prefer to build it yourself, you could say answer 2 is equal to the string version of numerator concatenated with a slash concatenated with the string version of denominator. And then we can print out answer 2. These will do the same thing. That's our 1/2. All right, so you can choose which of these you're more comfortable with. F strings are handy in most cases, although I would say they were a little bit annoying in this case. Didn't let us accomplish what we really wanted to accomplish. All right, so we've seen that we can have a representation of a fraction with a dictionary. And then we can go ahead and write like a supporting function that allows us to display that fraction in some sort of pretty way. Make sense? Now, it might be handy for us to create a class called a fraction. So I'm going to define a class called fraction. And this class is going to have a constructor that's going to take in, trust me on the actually it's not this, it's self in Python. So it's going to take in a numerator and a denominator. And we're going to say self dot numerator is equal to numerator. Self dot denominator is equal to denominator. And now we'll go ahead and we'll say a fraction 2 is equal to fraction 1/2. And then we'll go ahead and print a fraction 2 for right now, and we'll see what we get from this guy. Maybe we don't use def before it. Yeah, so fractions we don't have to put, or for classes we don't put def before it. So it's a class fraction and then it has functions inside of it. All right, so notice when I printed this guy out, it gave me this weird memory addressy thing. All right, so fractions, or any object that we build, is going to be built to be a place in memory that holds some stuff. But now I can say a fraction dot numerator concatenated with a slash concatenated with a, well, actually let's just, before I build the concatenation, I can say a fraction dot numerator, a fraction 2 is my object. Can't get it directly. All right, there's my one. It didn't like what I was calling stuff up here. I was passing it the wrong thing. So a fraction 2, this guy, which is a new fraction object, has a numerator that's 1. Similarly, he has a denominator, which is 2. All right, now I could write an external function here that knows how to display those things, or inside of fraction, I can create a display method, and we'll explain this self thing next time, but I can write a display method that will print out the string version. Actually, I'll just go ahead and it'll print out an F string. And we'll print out self.numerator and self.denominator. We'll talk through this next time, but now what I can do is I can create a fraction object, and then I can tell that fraction to display himself, giving me my 1/2. All right, so now I get the benefits of a dictionary in that I can hold a bunch of name value pairs, but then I also can build in functions specifically for working on those name value pairs and call them from main. So here's me creating a fraction object with my fraction constructor and then asking that particular fraction to display itself. And just to give you good code to compare, if I make this one 3/4, this will only take another 5 seconds. And then I say fraction 3 display. Now I'm using that class to create 2 separate fractions, asking each fraction to display itself. The first one displays 1/2, the second one displays 3/4. All right, so this is going to be our upgrade in many cases to dictionaries. I'll post this code up on Slack. Remember, homework due Wednesday is our last part from the regular expressions from last week, using a function called sub. And then we will keep going with classes on Wednesday. I'll post this up on Slack.